Yes, sir.
I think you are well prepared for class. Now look at this, your response. This is the first thing we are going to discuss. So it is wrong, first wrong, and you got the feedback, right? Here it's written, what is the purpose of the commutator in a DC electric motor? So here we got the answer C from you, to reverse the direction of the current in the motor coil every half turn.
Yes, sir. Because the
Your,
flow of the current and the magnetic field decides the motion.
yeah, your answer is not incorrect. I cannot say it's incorrect, but it's not appropriate one. Okay, why? The cause is they are asking about the purpose, and purpose is one thing that is related to the target, or what is the output of that. And the one you said, that is the process. Okay, how we are getting that? Is it clear? So our target is to do the reverse the direction of spin of motor coil every half turn, because the motor is rotating, right? Hello.
Yes, sir.
And our target is to get the continuation of the rotation, isn't it?
Yes, sir.
and and that is done by the reversing the direction of the current every half turn. So here is the tricky part, huh? Tricky part. We got a similar question. Why you chose it, I know. At the last, we have a similar question. You see, I'm also going there. Here, this question is given from your worksheet. I repeated this question. Yeah. Here, we chose here. Here, you see, to change the current direction in the coil as the coil passes the vertical position. So after the vertical position, we are getting the current direction change, right? Here, hello.
Oh.
So this one directly came from worksheet. However, you did mistake. You did this one in worksheet 22.
I mistakenly read the supply, what we call that means.
Yeah.
Just
So
I
this one,
misleaded that it will store energy. I just
okay. Now
I remember.
this one is saying the diagram shows why is a split ring commutator is used. So here we got this option only, so we have to choose this one. Nothing is there to choose, like the target or the purpose. Only they are asking why it is used, split ring commutator. That's why the answer is B, to change the direction in the coil as the coil passes the vertical position. Or what you said before, that every half turn the current direction is changed, right? Same thing, right?
Yes, sir.
So now I think it is clear to you the difference of these two questions. And this one already you understood, right? This one.
Yes, sir.
Yeah, that day you told me that you understood it later. This one is also a tricky one. You see here, we are not using any, you know, generator here for slip rings. Slip rings we learned for generators, but here slip ring is used in a DC supply, DC power supply. So what will be the you know consequence? The right side one is very much familiar with us. We know this is DC motor, right?
Yes, sir.
It will continuously rotate, so it does not have any problem to understand. But the left side one, as we have slip rings, there is something to think, isn't it? Look, when you are giving here electricity, this side, then how it is rotating, you can check with your fingers. North to south, this is first finger. Then, according to the direction of the power supply, we have direction that is second finger, the current direction.
So once again, please.
Yeah, look, we get here direction of current, right? It's towards the, for the left side we are thinking only, it's towards the screen, isn't it?
Yes, sir.
So you set according to left hand rule, not right hand rule, because the current we are getting.
These are motor,
Yeah,
and motor are normally
yeah,
used in DC supplies, not as
yeah. So
generators.
power supply we are having here, that is going through the first coil, left side coil in this direction, and also on the other side it will come towards you, right? And that is connected to other slip rings. So we will have rotation, right? How the rotation is working here in diagram 1, we are checking that field lines is first finger, then current is towards the screen, then we have our thumb downwards, isn't it? Hello?
Sir, uh,
Are we having the thumb
okay.
downwards? Check with left hand first.
But sir, no, sir, I'm having it upward.
What?
Sir, if I do it with my left hand, then my thumb will be up. And if I do it with my right hand, then the thumb will be down.
Look, is it really like that? I'm talking about the left side, like left side of the coil.
Yes, yes, sir, this
So
one,
if
sir.
you are
Right.
doing with, if you are doing with
Sir,
left hand,
okay, let me
you
show
have
you
to.
what I'm actually. This is the current for which it would be like this. This means into the paper. So
Okay,
my
okay.
index finger is going
I'm
into the
helping you.
paper.
I'm helping you. Wait. You take your left hand quickly.
Yes, sir, I have already took
Okay,
it.
so magnetic field means north to south.
Yes, sir, towards my
So
right.
if it is north to south, then this is our first finger.
The index.
Okay, then the current is towards the screen, right?
Sir, wait 1 minute, sir. These are our 5 fingers. Okay, sir. So this one is for current, means let this two be again go away. This is for current. This is for
This is,
magnetic
don't
field
say
lines.
this is that is. You say forefinger or index finger is for magnetic field.
Index finger is for magnetic field.
You forgot.
So just 1 second.
And middle finger is for current. That's why it's not matching for you. Do it fast.
This is the reason. Yes, and now it is going down.
So the thumb is going down, and for the right side it will go up, isn't it?
Uh, yes, sir.
Okay, now you understand. There will be
Motion magnet current like
there
this,
will
right,
be
sir?
one
Thumb index
anti-clockwise.
middle. Yes, sir.
Mm, there will be
Yes, sir. Anti-clockwise.
clockwise rotation, right?
Yes, sir.
Isn't it? And if it is anti-clockwise rotation, that time, if it is coming here, this right side one is coming left side and left side one is going to right side, then what will happen? What
Yes,
will
sir.
happen that time? What will happen that time?
Sir, could you repeat?
I said, what will happen that time if it is going one turn and
Sir, some EMF. Sorry, sir. It would be cutting the magnet. No, it would not. It would rotate. It would have a motion.
the left side one,
Sir, can you just clear this thing?
yeah, left
Because
side
I
one.
don't know why I
Hey,
can't.
listen, left side one, you see, makes 1/4 turn anti-clockwise, then it stops.
Oh yes, because it is always having a same way, same direction of the current.
Yeah, that's why. And the right side one, it will continuously rotate. Okay, anti-clockwise. So the answer should be C.
Yes, sir.
And look, here it's not matching. Continuously turns clockwise. D, right side for the right diagram is not matching. Coil Q.
Yes, sir.
So MCQ all are discussed, huh?
Yes, sir.
Understood them. Now we have two structured questions left. I told you to do homework, right?
Yes, sir.
Did you complete them?
So the last one is left. It is a simple one, but it is still left. I don't have confusion. I just didn't get it.
Okay.
Yes, sir. Complete.
Okay, complete, but I did not get the answers yet. I have to check.
Sir, can you just move my annotations because I don't know why I can't for some reason.
Oh, Allah Akbar. So this question we have to do, right? You have
Yes,
got
sir.
this worksheet printed, right?
Yes, sir. I told you in the
So
last class as well.
so label quickly label on the screen.
Yes, sir.
CSB. So which one is what?
Yes, sir. You got all of them.
Hmm. Yes, this one read.
Yes, sir. The AC generator is operating and the arrow on figure 5.1 shows the direction of rotation. Explain why there is an electromotive or EMF force between the two output terminal. So let me type down.
So what should be the answer of this? We wrote many times, right?
Yes, sir.
So what you wrote?
Sir, should I type it down?
Not necessary. You say. You type it
Okay,
on the
sir.
just quickly you say.
The coil's motion is producing induced EMF, which is moving in one direction as the other. uh, as the other side moves to the first one's place. Now it is also producing EMF, but at an opposite direction as the last one. So small gaps are present in the EMF supply as they are altering after every certain period of time at the end. Sir, when I'm just reading it out, it would be really awkward, but when you will read it, you will understand.
Why awkward?
Because I myself am feeling awkward to just like reading my things, what I just wrote.
Listen. I told you that this type of questions answer we wrote many times, right? Before this question.
Yes, sir. We
So
wrote it
so
many times, but I just didn't speak it aloud.
yeah, listen. There you get what is written there. Uh, your answer should be uniform, and there should be you can rely on.
So, sir, how much mark will I get, and what should have been the key points over here in the mark scheme?
The key points are here. Magnetic field lines are cut by the coil. Okay. which produces induced EMF.
Sir, so I should have also mentioned the magnetic field lines.
Have you written?
Yes, sir.
Yeah, what have you written?
Sir, I just put two stars and wrote magnetic field lines and EMF just beside the question over here so that I can just remember that even if I write like I just put a mark like this and star magnetic field line, star induced EMF, and then just left it.
So main thing is magnetic field lines are cut, right?
Yes, sir.
Done?
Yes, sir.
Karim?
Sir, can you hear me?
So this one also you know.
Sir,
See,
sir, can you hear me?
I can hear you.
Oh, I thought
See,
that you're just speaking and took my name
see,
because
see.
I thought you can't.
Part C you do. You
Yes,
can
sir.
do it.
Okay, sir. The output terminal of the AC generator are connected to a cathode ray or oscilloscope.
Hmm.
Oscilloscope, CRO in short form, shows the trace on the screen of CRO in speaker
So you
5.1.
already know it, right? What
Yes,
will
sir. It is like the graph we did
yeah,
in
this one,
class.
right?
Yes,
Then
sir. Describe how the trace and a setting on the CRO are used to find the time for one revolution of the coil of the AC generator. You may draw on figure if you wish.
so this one you already know, right?
I gave it like this for time t, and
Yes, Karim.
yes,
You
sir.
got this description, right? How to calculate it.
Yes, sir.
So you write that in 2 points. First you find number of divisions, right? Then multiply number of divisions by
By the time t.
the time base, not the time base.
Sir, actually I wrote it something else, but I just didn't thought that I could just do that.
Yeah, time
Uh,
base. You write time base. Time base is meaning that
uh,
is
it might
division.
take as much as long as it can, but we will just divide number of waves with that time which we at the till we measured.
Yes. So done. This one is done, right? What you wrote?
Sir, I wrote something else. I wrote that the AC generator once produces positive EMF and then negative EMF, and then again to positive. The starting of the graph to the starting of the second, means the second wavelength. If you see the arrows in the, if you see the arrows is one complete revolution. So that is the reason I drew it on the,
It's
they
fine.
said
It's
if you
fine.
wish.
It's fine.
So sir, will I get
So there should be 2 points. I already told you. What are the 2 points?
uh,
First point is
measure,
you should find measure the number of divisions for a complete cycle. Okay.
oh, a complete cycle.
Yeah.
So there are two divisions.
Why?
One is the positive EMF side and one
Okay.
is the negative EMF
One,
side.
two, three, four, five. 5 divisions. 5 divisions means these squares are called divisions. Okay. One,
Okay, sir.
two, three, four, five. Right here, number of first find number of divisions. Ah, then you write multiply with the time base per divisions.
Yes, sir.
Multiply with the time base per divisions. I am showing you one example.
Uh,
Otherwise, you will not understand. I think you
sir, are
can't
you
remember.
having,
Okay, look,
sir,
I'm
are
writing
you,
here.
sir, are you having net problem because you are lagging?
5 divisions for a complete cycle.
Sir, you wrote time spelling wrong.
Yeah, you write correct.
EIM.
Setting, right? Setting, time base setting.
Yes, sir.
5 millisecond per divisions. Okay.
Okay.
So time period here, how much?
Uh, 5 into 10 is equal to 15 millisecond, means half a second.
Yeah. So time period is here. 5 5s are 25, right?
Yes, sir. 25 millisecond for one complete revolution, and
Yeah, that's it. Time period is it 25 millisecond. One revolution, that's why it is time period, isn't it?
yes, sir.
Now, this way we are calculating here. Okay. First we find the number of divisions for complete cycle. Then we get the time period by multiplying time base with the number of divisions. Okay.
Yes, sir.
This is the way. Now it's clear to you, right?
Yes, sir. Just let me write this as well. So, means as an
This is
example, I
just
will.
one example, but what
Yes,
you
sir.
have
This
to,
example will always remind me the thing.
yeah, and the points will be like that. What I am writing here. Number one, find the number of divisions for complete cycles. Then second step is multiply multiply number of divisions by
So why don't you just move this thing to here, then it will be in one line.
time base. Yeah. So it's clear to you now.
Yes, sir.
This way the horizontal axis we are applying. Now next one. Are you done with writing?
Yes, sir.
Okay, then read.
Yes, sir.
Read
Question
fast.
number 6. A primary coil of a transformer is connected to the 230 volt AC main supply. Describe how the transformer operates. The primary coil is the one. Okay, describe how the transformer operates. So what I wrote is the primary coil is the one which is connected to the main supply. It forms a coil in one side of the iron core which act as a magnet. Due to the AC current, the poles of the iron core magnet keep changing, for which the coil on the other side of the iron core is cutting the moving magnetic field lines to produce induced EMF, which we use and call electricity.
Yeah, and you mentioned there that this induced EMF is produced in secondary. Okay, always we are getting the induced EMF in the secondary. In the primary, we are giving the power supply from mains AC supply, and in secondary, we are getting the induced EMF. Is it clear?
Yes, sir.
And you also mentioned that in the secondary we have either more number of turns or less number of turns than the primary. So accordingly, there will be step up or step down transformer. Okay, there will
So
be
do we need to mention that step up or step down?
no,
They
no
just ask that how it works.
yeah. How does it works? Uh, Actually, in transformer we are not getting the same voltage, right? We are getting induced voltage. This is fine, or induced EMF we are getting, but we are
Sir, so should I just say that we can change the
yes. This
voltage
is
or
this is the
amount of
this this is the
uh,
main task of transformer.
so we will just say that we can control the induced EMF producing by number of coils in the secondary
Yes,
coil.
yes, yes. This is the main task of our transformer. So why we are using it? We have to change the voltage, right?
Yes, sir.
That's why we are using the transformer. Otherwise, we don't need transformer. Okay, the next,
Didn't did it yet because I can't.
we read.
Sir, I didn't did it.
You read.
Sir, I'm just writing this point which you just said. Yes, sir. The
Right.
output voltage of the transformer is alternating and cannot be used directly as an AC power supply.
DC.
Yes, sir. DC. Sorry, sir. In the second space below, draw the symbol of a circuit component that allows the current to pass only in one direction and state the name of the component. Sir,
So that is
split ring,
this is
split ring,
no, this is diode, huh? Diode.
diode.
To convert AC to DC, we use diode. Diode is allowing the current to flow in one direction, isn't it?
There is diode something like this that both
Yeah.
of the AC power supply wires are connected in one point, and this wire goes just a single way for which this half and this half just joins over here as a big one. Sir, is the work of diodes something like this?
Work of diode, we got in DC circuit, current electricity topic. There we got little bit, not that much. More we'll get in topic 24. Okay, so this part is negative, this part is positive.
Okay, sir.
So it has polarity, yeah. Only it allows current to go through one direction. Okay,
Yes, sir.
that's why it's converting AC to DC.
But sir, I still don't understand. Like, is
We
this
will
the way
make
what
you,
I just said?
hey, make you just write. It is a component which allow the current in one direction. Write it, and more details we will discuss in next topic. Okay, how it is doing that.
Okay,
Is it
sir.
clear? In the
Yes, sir.
introductory electronics, we will do that. So our worksheet is done. Okay,
Yes,
you
sir.
write only diode is a device or component which allows the current to flow in one direction, which converts AC to DC. Are you done?
Yes, sir.
Okay, then our worksheet is over. Now we have the test on structure part.
Sir, how much time do I need it
You
to
need
complete that?
40 minutes exactly. Actually, we had plenty of time, but you were late to join the class. That is the main problem. Now I need 2 or 3 minutes to give it in the G class. Okay, the link I'll give in
Yes,
G
sir.
class comment. Today's posting comment after 2 3 minutes you check, huh? Then you'll get it. Okay, you have to upload one picture in PDF format. Okay, if
Sir, picture means I don't have space to write.
yeah, you have to draw the diagram and you have to convert it to PDF
Sir,
format,
is
then
it,
you upload.
sir, is it okay if I like do it in my Word or something like that, and then
Yes, it's
just
okay.
take a
Then you
screenshot and give you?
yeah, okay. In you should upload it in the question paper.
Sure, means the diagram of which one I will paste it in a single one. Means question number two's diagram in question number two and three's one in three, not like
Yeah, only
all
one
of them.
diagram is there. Only one diagram is there.
Okay, sir.
Okay, then no problem. Then if you are not able to do that, then only send it to Physics Mania Gmail. Okay,
Yes,
that
sir.
will be also okay. Is it clear?
Yes, sir.
Okay, thank you. Huh? That's all for today. Huh? Next class we will continue topic 24 introductory electronics, but I will upload the notes. Your homework is to go through the notes, okay? At least once you should read it.
Okay, sir.
That is your homework.
Sir,
Yeah, tell me, quick.
no problem, sir. It's okay.